this video, we are talking about anomaly detection using embeddings and GenAI. And we have today Kyra with us. Hi, Kyra.
Hello.
So Kyra wrote an article that went viral into the Databricks community edition. And Kyra, can you tell us a little bit about the blog, the idea behind it? How did you come up with that?
Yes. First of all, thank you for having me here, Lara and Maria. So yes, this came out from a project we were doing where we had procurement data, and we wanted to explore how to leverage GenAI in order to detect anonymous anomalies purchases in the data. The data was huge. And as you can imagine, in normal anomaly detection use cases, you have very little samples, or you can say, yes, we can learn easily from that. So it required a vast processing of data. So this is why the idea of it was also the nature of data was mainly text data, describing the product, describing the vendor providing those products. So that's why the idea of first using embedding came into play, as we can have in this numerical representation the semantic meaning of the text, and then it's easy to find relationships as well. And then LLM came as well as, okay, LLM is really good at understanding language, and how can we give something extra from what classic machine learning algorithms can give us in normal anomaly detection use cases. So that was like the main inspiration, how we came up with, let's use both of them and see if the results are better than using the classical models.
Okay, so it's kind of a hybrid approach. You do the traditional part and then you put on top some LLM part as well. Okay, amazing. Let's go through the blog a little bit and see what we've been explaining there.
Yes, so the blog, you can find it in the community portal of Databricks, where data practitioners, they share their knowledge, their experiences. So yes, the blog goes through the approach we went through, why embeddings, how to approach it with classic ML, how LLMs can help to get something new out of it. And the main idea is not like how to do things, but more like inspire how you can leverage both worlds, something we are very familiar with in the data science world, all these algorithms we have already in production and so on. And how can we leverage adding this amazing capability from GenAI on top of it?
Amazing. So in this case then, why embeddings? Why did you choose to use embeddings for?
Yes, so because of the nature of the data, we wanted to have this textual and contextual information that we could then leverage in order to see if there were some differences or some anomalies there. For instance, here, this is just a graph to show if we have embeddings that are similar to each other, then it will be easy to group them. And if you have maybe something that is quite different from those kind of words, of those descriptions, it will be out of that group, of that cluster, and it will be detected as an anomaly. So there are tons of algorithms that exist to do this. So here we are using PCA just for demonstration purposes, but you can use clustering, isolation forest, other dimensionality reduction algorithms as well.
And then what is the LLM aspect on this? So how does the LLM enhance the contextual understanding of the anomaly?
Yes. So the LLM here gave us a really interesting flavor, because with anomaly detection, you could see like, okay, there was like a first step of detection, which was okay, but it was missing some context. For instance, maybe a vendor is providing a set of products related to a particular area, but there is also like delivery charges associated to what is offered by this vendor. And that was very hard for the traditional machine learning algorithms to catch up. This contextual, like, well, that's part of what the vendor provides, even though it's quite different from maybe very techy tools, specific tools. So what you can use the LLM to provide this additional context. You can provide it in your prompt, or you can provide it with a RAG approach or tools with agents. You can give the LLM this information when actually it's normal for vendors to charge for delivering the things they produce. So these kind of use cases, they are very hard to teach a classic ML algorithm. It's hard, and it's also, it requires a lot of effort, feature engineering, retraining, testing. So with the LLM, you can add this context that will enhance as well your result, and it will also reduce false positives.
Amazing. And then how did the architecture look at the end with the LLM aspect?
Yes, we have So in the hybrid approach, what we have then is like you have your raw data, you pre-process it, then you get an embedder, and there are very good embedders out there. Here for this approach, we use GTL large. Then once you get your embeddings, you go through your classic ML algorithm, and then you get a first layer of flag anomalies.
Yeah.
And then the approach we had here was to take all those vendors that were at least one, had at least one flag anomaly, and then we took all of them with their unique products and sent them to the LLM, and asked the LLM to confirm and also to provide a reason. And this interpretability is also something that is very useful, because in this particular use case, what is happening now before this approach is that there is a manual, very long and manual process in order to detect if something is anomalous and then report it. So in this approach, you will have still the human at the end of the loop, but this human will be then having a very specific short set of reported anomalies with an explanation as well. So it will be also easier for this expert to evaluate if it is one that is worth reporting and investigating or not. So that's also something that is not easy to get from the classic ML approach.
Very cool. Yeah, nice. And the evaluation and the explanation why the LLM flagged this or agreed that this is an anomaly. Really cool.
Amazing. Maybe with just one question. So, LLMs can be computationally expensive. So how did you manage to balance, accuracy, interpretability, scalability in your solution, bearing in mind, the cost?
Yeah, excellent question. Exactly. So because you could say, well, if it is so good, why don't you just send all the data to the LLM and that's it, right? Which could be an option, but an expensive one, especially if you have like millions of data. So yes, with this approach, you can do just like that big bulk of the data processing through a classic ML. It will have lots of false positives, but it will be already a first filtering of the data. And then when you go to the LLM, you can then get a much better accuracy at less cost. And it's also more scalable as well, because usually when you run a classic ML algorithm, it takes just a few seconds or few minutes to run. And it's inexpensive. And then you invest just in that final layer to get your polished results.
And also it's kind of a nice way to keep using your current ML approaches and just augment them instead of just replacing them completely. So it's a really nice, beautiful hybrid approach, this one.
Exactly. Especially, it's very hard to get a product, a data science product to production, being accepted by all the stakeholders and so on. So it's also difficult for industries to say, okay, let's replace this completely by something quite new that will have to go through all that same process of acceptance and so on. So it's also a nice way to get to that transition using the latest technologies at a lower cost and effort as well.
Amazing. Yeah, I really like also just the fact that it really helps mitigate the common issue of having the false positives. So I think it's a really cool solution. I really love the hybrid approach. Just one other question, like what improvements do you consider like in the future? Have you considered, fine-tuning models or integrating additional contextual data?
Yes, and that's another power of LLMs that you can, for instance, let's say we have identified some anomalies, and then we can empower the LLM with, for instance, additional context from your knowledge base, with contract from the vendors in order to ensure that those products that you have found as anomalous are actually not in that contract of products they sell. And that will be better than the prompt engineering that we have at the moment, where you have like a long prompt saying, consider this, consider deliveries. So that will improve accuracy. Also, another option will be fine-tuning, as you were mentioning. So for that, though, the main limitation is the data set to do the fine-tuning. So because these anomalies, they don't happen in tons, they are anomalies. So you will need to curate that data. So you will need to have like a started data set, even if it is small, that is a good quality one. From your historical data, and then you could use synthetic data based on that data in order to fine-tune a little LLM and get better accuracy. That will be the next approach. But already having the RAG or some tools helping the LLM to get even better at the decision making, that will be a next step that will improve even more the accuracy of the solution.
So one question on my side. So in this current approach, did you see, with the addition of the LLM, what performance improvement did you see, or what reduction of the false positives?
Yeah, so actually, at least 1/3 of the false positive of the positive classified by the classic ML was filtered down by the LLM. This was relatively small data set, and we have like the human evaluation at the end.
Yeah.
But already you could see that. And also that having the interpretability, the reasoning at the end why is quite helpful as well, to say, okay, this is right or not. So in order to do this human in the loop evaluation, that was very quick. But yes, this evaluation as well could be improved by creating synthetic data to have more samples to evaluate, and then have a more robust benchmark for your evaluation.
And if people are interested to know more about that, we actually have also an interview with Michael Stelma on how to, fine-tune models with synthetic data. So people can check that video.
Yeah.
Cool. Let's go through the demo.
Good. So accompanying the blog, you will find also a GitHub repository where you see some sample code there. So there are mainly 2 notebooks based on synthetic data. In the first one, what we are doing is just using a classic machine learning approach in order to detect anomalies. Here, for demonstration purposes, we use PCA based on your data, so it can be another one. So we first embed the data, run the PCA code. Is just like boilerplate code, but interesting is that here what we are using is the reconstruction error of the PCA components in order to judge if that embedding might be anomalous in comparison to the principal components. And here the key is to figure that threshold. When do we say that it is anomalous? So you can see here an example where we have different construction related products, and then there is cloud software. I know this is an extreme example, but you can see here the the reconstruction error is quite high in comparison to the others. So it's above the 99th percentile. So it's considered an anomaly, for instance. So this is what this notebook is giving you. And here, for instance, we have the delivery fees use case I was mentioning before, and something also, again, very out of the normal bakery tools. Is not related to anything of this construction hiring tools. So these two are considered anomalous, but as I was mentioning before, delivery actually could be something quite normal for this particular vendor. So that's something you can fine-tune with the LLM very easily. And then the second notebook is how to use that data to then feed the LLM and get your output. So here we are using as tools just the enforcement of the output, because if you ask an LLM just with a normal prompt, can you identify the anomaly and give me a reason? It will give you an answer, but it won't be easy to read. So it will be based on your data, I have found this and this and that, which is nice. But if you're a human reading or if you want to automate that evaluation, it's hard. So if you instead enforce an output in a JSON, for instance, then it will be much easier to just process it and read it after all.
So in this case, you were enforcing what exactly? So what was the schema? So the anomalous product, if any?
Exactly. So I'm here sending, I'm taking from the previous notebook all the vendors that had at least one anomaly product that has been purchased, and I'm taking all of them. For instance, here, this vendor with these particular products, I'm sending them to the LLM. The LLM has this tool here where I'm saying, if you identify the output, so say if it is anomalous or not, and provide a reason in this JSON format. This is the bit of enforcing the output. And this is the prompt where I'm telling you are analyzing the products, finding anomalies in there. Do not consider anomalous anything that is related to delivery, transportation, and so on. A few short samples here as well in order to enforce that, and how I want the output, also to enforce how I want to have it, although you need the tool in order to get it working correctly. And then yes, so you get as a result this kind of output where you have then what is the outlier and what is the reason for that.
Oh, cool. And the reason is what you said before, that you give the explanation why that was flagged as an outlier.
Exactly. Cool. And here we have an example in row number 2. You have an example, for instance, of a false positive that says, actually, this is not an anomalous purchase. And why? Because all of these products seems to be related to the same area. And this contextual bit is what the LLM is providing here, is the add-on. So, and that's it. So it's just like a demo to show the capability. And besides this application, I will be super interested to hear any other application that I have heard from people using LLMs to have nice report on shop values, on casualty, or to analyze the output of classic ML as well in a business-oriented way or a particular language. So I think this is a potential we have here to find many other use cases.
Yes, good point. Please comment if you have seen other interesting applications of this hybrid approach, either in Kyra's blog or in the YouTube channel comments.
Yeah. I have an example where it was the other way around, where it was using LLM first and then using the classic, traditional ML model in order to classify some video ads. Because initially it was only the traditional ML approach, but as you mentioned, Kyra, this was not scalable because it was classifying across millions of categories, new categories were appearing every day. And so it was just really hard to keep up like with the traditional model approach. But yeah, here it was the other way around. It was LLMs and then classic ML. That's definitely something that we should think of like more often. And I think this solution is awesome. I just love like the model response and the context and, the reason for the, like for classifying it. It's really cool.
Amazing. Thank you. Thank you, Kyra.
Thank you both.